Hi, everybody. In class today, we started to explore the concept of air pressure. And we did a bunch of demonstrations, and we had a lot of fun in class today, right? We laughed a lot. What I want to do in this video is I want to introduce you to the three factors that affect air pressure. So let's just do a quick recap of what we discovered in class. Air pressure has a few names. We also call it atmospheric pressure and barometric pressure. They all mean the same thing. And we know that air pressure is caused by the weight of the air or the atmosphere that's pushing down on the earth. And it works the same way as in a football game when somebody is getting tackled. The person on the top doesn't have anybody on top of him, so he's not really under pressure. The poor guy at the bottom, however, is under a lot of pressure due to the weight of all of these other people laying on top of him. So with air pressure, it works the same way. There are three main factors that affect air pressure. The first one is temperature. Now, I want you to keep in mind that air pressure is a force, a squeezing force, right? Pressure is when things are getting squeezed. And so is density. Density is how tightly compacted the molecules are. In a lot of ways, density and pressure are the same. And if you think about them as being the same, it makes it much easier to understand this. So let's say that, one morning it's pretty cool and the sun rises and the air warms up. Well, you hopefully remember that if the temperature increases, the molecules will expand, and that will make the air less dense. And if it's less dense, there's less pressure, because if the air is able to expand, then it's getting squeezed less. And the opposite is true also. If it gets colder out, which would make Olaf very happy, then we know that the molecules are going to contract. They're going to move closer to each other. So the air becomes more dense and is under higher pressure. Okay, so that's temperature. The second factor that affects air pressure is the humidity, or the amount of water vapor in the air. We know from our reference table that dry air is composed of 78% nitrogen and 21% oxygen and 1% other elements. When air is wet or moist, there's also water vapor in there. Okay, so really the only difference is we have this additional hydrogen and we have some more oxygen. Well, it turns out that hydrogen is the lightest element. So if there's water vapor in the air, it means there's hydrogen in the air. In order for the water vapor to fit, some of the nitrogen gets pushed out. Okay, look at how many red circles there are here. You'll notice there are far fewer of them when the air is moist. That's because the water vapor is pushing out the nitrogen. Like I just said, water vapor is lighter than nitrogen because the hydrogen is lighter. If air is lighter, it can't exert as much force or as much pressure. So, if the amount of water vapor increases, if there's more water vapor, it means the density and the air pressure will be lower because the water vapor has hydrogen, which is lighter. If there's less water vapor, then the air will have higher density and higher pressure because now it's got a lot of the heavier nitrogen in it. And if it's heavier, it has more pressure. It can exert more force. The last factor that affects air pressure is altitude or elevation. So let's say that after school today, a few of you decided that you wanted to go enjoy the beautiful day. And so you went to some different landscapes. So let's say that Gwen decided she wanted to just sort of lay down on this flat plain over here and she's going to read a book. So that's Gwen. And let's say that Brian decided he was full of energy. And so he was going to climb up this mountain. And when he got to the top, he was going to put his arms up and he was going to do King of the World. So there's Brian. And let's say that Abby decided that she was in for an adventure too, but she wanted to rappel down into this canyon and take a look at what was going on at the bottom. So there's Abby. So each of these people is being exposed to a different amount of air pressure. The question is, who is under the most pressure and who's under the least? Well, if we go back to our definition, that air pressure is caused by the weight of the air above you, it becomes pretty clear that Brian has the least air above him because he's high up. So he's got a little bit of air pushing down on him. Gwen on the plane has all of this air above her, and gravity is pulling it all down onto her. So she is under much more pressure than Brian. Now, Abby is the farthest down. She's at the lowest elevation. So she has actually got the most air above her pushing down on her. So Abby is under the most pressure. So the relationship here is that as altitude goes up, the higher you are, the lower the density, the lower the pressure. Some of you may have experienced this. If you've ever gone skiing, if you've ever gone to the top of a mountain, it's often harder to breathe. And the reason is that there's actually less air when you are at a higher altitude or a higher elevation. As you go down, or as your altitude decreases, density and pressure will increase. You're under more pressure the lower you go. Now, most of you have probably been on an airplane at some point, and some people can have a lot of discomfort when they're flying. Some people have a lot of ear pain. So let's take a look at why that is. When the plane's on the ground, you have the weight of all the air above you pushing on your eardrums. Now you're used to that because every day we have that amount of pressure pushing on our eardrums. Then what happens is the plane takes off and the pilot takes the plane higher and higher and higher. When the plane goes higher, there's now less air pushing down, so there's lower pressure. Because there's less pressure, it actually lets your eardrums bulge outward. Some people find that to be uncomfortable. Most people can handle that. The real problem comes for people when the plane lands. Because when you're up here, like I said, your eardrums are bulging outward. As the plane starts to land, you're under more and more pressure again. And so that pressure actually pushes your eardrums inward towards your brain, and that can be very, very painful for people. So this is a great example that many of you have probably experienced. A very similar one would be if you're driving up a mountain. Sometimes you'll feel your ears popping. And that's because, we put a mountain here, when you're driving up the mountain, there's less and less pressure. And so that affects your eardrums. You may also have experienced something very similar when you're swimming. So this would be water pressure as opposed to air pressure, but it works the same way. If you're in the shallow water, your ears are usually okay because there's just a little bit of water pushing down on you. But if you go to the bottom of the pool, like to the deep end especially, your ears will hurt. You will feel that pressure of all the water pushing on you. Okay, so this all works the same way, air pressure, water pressure. So quick recap, if the temperature or the humidity or the altitude increases, the air pressure and the density is going to decrease. However, if the temperature goes down or the humidity goes down or the altitude goes down, then the pressure and the density will increase. So what do you notice about these two sets of relationships? Hopefully you're noticing that they are all indirect. And that is a very helpful way to remember the air pressure relationships. I will see you tomorrow, and we will continue to investigate air pressure.